Welcome to the McDaniel College Laboratory Safety Training. Today we will be talking about safe practices within the laboratories to help ensure your safety and health. Our goal is to ensure that you go home at the end of the day at the same way you arrived this morning. Employee and student responsibilities. You must perform work in the safest manner possible. You must follow all college policies and procedures. You can find the Forms and Policies page on the portal under Faculty and Staff Resources. You are to report any health or safety hazards to the Office of Risk Management and EHS. It is the responsibility of the faculty member to continually train their students in all lab procedures. Dress code when walking into a lab. When walking into a lab, no matter what you are doing in that lab, you are required to wear the following: long pants and closed-toed shoes. Dress code when working in a lab. When working in a lab, you must be wearing the following: long pants that extend past the ankle. Leggings, spandex pants, tights, and yoga pants are not acceptable substitutes for long pants. Closed-toed shoes must cover the entire foot. Flip-flops, sandals, ballet flats, Crocs, or high heels are not acceptable substitutes. Hair should be tied back, and exposed midriffs are not permitted. Personal protective equipment, PPE. Lab coats. Lab coats must be worn while working in the lab and must be fully buttoned. Chemistry lab coats are disposable coats made of Tyvek or a Tyvek alternative and are white. Use care when working around open flames in Tyvek lab coats. Tyvek can melt when exposed to direct heat. Biology lab coats are disposable coats made of a non-woven fabric and are blue. They do not offer protection against chemical splashes. Students may also wear cloth lab coats in any lab. Personal protective equipment, PPE, lab coats, continued. Students should print their name in marker on the back of the disposable lab coat. Students should not share lab coats. Student lab coats are to be kept in storage bags in the designated drawers or plastic storage bins within the lab. Lab coats cannot be taken back and forth between labs. Cloth lab coats must be laundered after each semester prior to the user removing their lab coat from the building. Personal protective equipment, PPE, eye protection. Safety goggles have guards on the side of the face and a shield on the top of the goggles that meet the forehead. Prescription glasses and contact lenses do not provide protection. Safety goggles must be worn in the following scenarios: handling chemicals hazardous to the eyes, using chemicals with unknown hazards, working with gases, working with liquids which are hotter than 60 degrees Celsius or 140 degrees Fahrenheit, working with solid materials, for example, glassware, or equipment that may cause fragmentation or flying particles. When dust or fumes are present, working with preserved specimens during dissection activities. Personal protective equipment, PPE, hand protection. Ensure you are using the correct type of glove to protect you against the materials that you are working with. Rings should not be worn under gloves as they may puncture the glove. Remove gloves when touching any surface in common areas such as hallways, keyboards, doorknobs, elevator buttons, etc. Remove gloves when leaving the lab. Use a cart or secondary container to carry hazardous materials in the hallway. General safety rules. Students may not remove any biologicals, chemicals, or reagents from the lab without the permission of a faculty or staff member. Do not use broken equipment, place out of service, and inform a faculty member. Keep cell phones, extra books, clothing, and personal possessions away from the lab bench to prevent contamination. General safety rules. Continued. Lab doors must be closed and locked when work is not being conducted. Use the buddy system while lab work is in progress. Faculty members must be aware of the work students will be doing. Projects involving chemicals on the high hazard chemical list must be conducted with a faculty member present. After hours work. Faculty members must send a list of student names and permitted room numbers to campus safety at the beginning of each semester. The students must call campus safety to be let into permitted rooms. Students must have a buddy and must show McDaniel ID for access. Lab hygiene. Eating, drinking, chewing gum, applying any lip products, and/or makeup is not allowed within the labs. Do not put any pens, pencils, or gloves in your mouth during lab work. Wash your hands with soap and water whenever reagents contact the skin and before leaving the lab. Keep the lab clean. Wipe down the bench top with the designated cleaning material after each experiment. For work involving bacteria, lab benches must be disinfected with an EPA-registered disinfectant after each lab experiment. Return chemicals and equipment to their proper places, dispose of trash, and make sure the drains are uncluttered. Housekeeping. The laboratory should be kept clean by wiping down the counter with the designated cleaner after each lab experiment. When working with bacteria, lab benches must be disinfected with an EPA-registered disinfectant after each lab experiment. Return the chemicals and equipment to their proper places, dispose of trash, and make sure the drains are uncluttered. When using gas or vacuum outlets, make sure they are turned off before leaving the laboratory. Return any personal protective equipment to its designated location. Blackboard Safety Course. Students must complete the lab safety training on Blackboard by the deadline provided. Training and quiz are the same format as last semester. Lab safety agreements are electronic and can be found immediately after the lab safety quiz. Any students registered after the deadline will need to be added. Please let me know who needs to be added to the Blackboard as soon as possible. Typical questions. Why is the page blank when I click on the link? There is a Mark Reviewed button that they must click to proceed. Why am I still on the list that I have not completed the training? You may not have completed the lab safety agreement. Fume hoods. Face velocity should be around 100 fpm at the sash height of 18 inches. Ensure sash height is not above the sash line indicated by the sticker. Work with the sash between 12 to 18 inches high, depending on the user's height. Ensure all chemicals are in secondary containers within fume hoods due to sinks. If there is a problem with the fume hood, close the sash, place out of order sign on sash, and contact physical plant. Chemical inventory. A collective list of all chemicals in each lab and on campus. All chemicals must be barcoded. Remove the barcode from chemical container when empty and place in the waste area. Sean or Katrina will remove barcodes from inventory. Chimera is our chemical inventory provider. It is reconciled yearly. All faculty should have their own login for Chimera, and students can obtain access on a case-by-case basis. The chemical inventory is submitted to the local fire department. Safety Data Sheets, SDSs. SDSs explain all the necessary information for the chemical. Information on the SDS must be presented using specific headings in a specified sequence. They must be in English, and they must be readily available to all employees during all work shifts. They can be found in binders or through electronic access in Chimera. Chemical labeling. All chemicals must be labeled with the contents. The full chemical name must be written out. Abbreviations and chemical symbols do not meet regulation requirements. Household-grade chemicals do not need to be relabeled, as the manufacturer's labeling is adequate to communicate the hazards. Primary container labeling, otherwise known as the manufacturer label. They use the Globally Harmonized System, or GHS, for the classification and labeling of chemicals. Workplace container labeling, otherwise known as the secondary container label. We use the Globally Harmonized System, or GHS, for the classification and labeling of chemicals. Proper labeling under GHS. Each label must contain the following. A signal word. It indicates the relative level of hazard. Danger is used for most severe instances, while warning is less severe. Symbols. Hazard pictograms. These convey health, physical, and environmental hazard information with red diamond pictograms. They may use a combination of 1 to 5 symbols. Each label must have the product name or identifiers. As you can see on this label, it is found in the top right corner as carbon monoxide. Hazard statements. Phrases that describe the nature of hazardous products and oftentimes the degree of hazard. Precautionary statements. Phrases associated with each hazard statement that describe general preventative, response, storage, or disposal precautions. Manufacturer information. Company name, address, and phone number. GHS pictograms. Hazard pictograms and related hazard classes. The following are all pictograms that can be found on any GHS labeled container. From the top left to the bottom right, they are as follows. Exploding bomb, corrosion, flame over circle, which indicates oxidizing agents, gas cylinder, environment, skull and crossbones, which indicates acute toxicity, exclamation mark, which indicates it is an irritant, a skin sensitizer, acute toxicity, narcotic effects, respiratory tract irritant, hazardous to ozone layer. Health hazard, which indicates a variety of toxicities and carcinogen effects. Flame, which indicates that the substance is flammable. A DOT label is separate. A bottle will come with a GHS label on the container, and the box will be DOT labeled. An FPA 704 diamond. The label is to be filled in with the chemical name with no abbreviations, the owner, and the date. The diamond must be fully filled out using Chimera. If filling in the diamond for 2 or more chemicals, look up both chemicals and take the highest number for each color. There are 4 categories to label in. They are as follows: health hazard, fire hazard, reactivity, and specific hazard. Chemical storage guidelines. All stored chemicals must be labeled. This minimizes the hazards associated with accidentally mixing incompatible chemicals. Never sort and store chemicals alphabetically. Store all chemicals by their chemical family, such as acids, bases, flammables, etc. Ensure caps and lids on all chemical containers are tightly closed. Never store chemicals under sinks. Never store chemicals above 5 feet or eye height. And never keep expired chemicals. If you have any questions on chemical storage, please ask. Cylinder storage. Always secure cylinders with straps or chains connected to a wall bracket or fixed surface, or place the cylinder in a rack or stand. Always keep cylinders upright. Separate the cylinders by compatibility. Ensure that each cylinder is stored in a cool, dry, well-ventilated area. Ensure the usage tag indicates correctly the volume of the tank that is left. When cylinder is empty or not being used, ensure that the valve is closed. Waste management. Different types of waste streams are as follows: hazardous waste, biohazardous waste, universal waste, non-hazardous waste, and radioactive waste. Each waste stream is disposed of in a different manner. Hazardous waste, radioactive waste, biohazardous waste, and universal waste are carefully tracked. Please be conscious of all types of waste. If you are unsure of how to properly dispose of your waste, please contact the Office of Risk Management and EHS. Hazardous waste. Hazardous waste is regulated by the EPA and the MDE in the state of Maryland. Waste is considered hazardous when it shows characteristics of ignitability, corrosivity, reactivity, toxicity. The following are the listed hazardous wastes. The F list, which is a nonspecific source waste, for example, spent solvents. The K list, a source-specific waste, for example, ink sludges containing chromium or lead. And the P list and the U list, which are discarded commercial chemical products, for example, sodium azide or acetone. Hazardous waste. Satellite accumulation areas can be found in many of the labs. Hazardous waste is held here until it is transferred to the central accumulation area. We have a contracted vendor that picks up all waste from the central accumulation area. The central accumulation area and the satellite accumulation areas are highly regulated by the MDE. Hazardous waste. Title 40 CFR. Resource Conservation and Recovery Act, otherwise known as RCRA, requires the EPA to publicize and enforce regulations regarding the management of hazardous waste. Mandatory procedures for compliance must be followed by facilities where haz waste is accumulated, transported, treated, or disposed. Under MDE, we are classified as a large quantity generator. Waste must be removed from campus within 180 days of the accumulation start date. New setup for waste containers and labels included in 103, 301, and 208 for small, medium, and large containers. Ready for disposal labels can be picked up in 301 and 208. Chemical waste. Waste from lab courses. Discarded into the pre-labeled containers placed out by the chemistry lab manager or biology lab manager or instructor. Waste from research labs. Place a hazardous waste label on the container and fill out the label completely with chemical contents. Again, no abbreviations, amount, and start accumulation date. Place into the secondary container in the satellite accumulation area. As for chemically contaminated sharps, please place them into the white puncture-resistant sharps containers. Fill out the label with what the sharp was contaminated with. On this slide, you will see a hazardous waste label as we have previously mentioned on the last slide. The hazardous waste label is required to have hazardous waste written on it in plain English. This can be found at the top center of the label. Moving down from the top, we have a line for the date, which will be the start accumulation date, the lab that the waste has been accumulated in, and the staff or faculty member that has began collection of the hazardous waste. Moving further down the label, you will see that there is a spot for you to write the amount, concentration, and substance that you have placed into the hazardous waste container. At the very bottom center of the hazardous waste label are the GHS pictograms, which you must circle depending on what you have put into the jar. Biological waste. Animal carcasses and tissue are collected in the labeled bins. Sharps, such as needles, syringes, blood tubes, etc., must be placed in the red puncture-resistant sharps containers. Autoclave items are collected in labeled bins with the clear bags. Biohazard waste that cannot be autoclaved is collected in the biohazard boxes with the red bags. Empty containers. Empty manufacturer containers. Leave the empty manufacturer chemical containers in the satellite accumulation areas. Ensure that the barcode on the chemical is not removed from the container. Empty the secondary containers. Remove or deface the label with permanent marker. Rinse the container out. Rinse into a waste container or place full container into satellite accumulation area if it is a P-listed chemical. Other types of waste: universal waste, bulbs and batteries. Contact the Office of Risk Management and EHS for disposal. Non-hazardous waste. All non-hazardous waste can be placed in the trash unless otherwise specified. Gloves and paper towels, unless heavily saturated with chemical or biological material, can be placed in the regular trash. Non-contaminated broken glass should be placed into the broken glass boxes, which are labeled cardboard boxes that can be found throughout the laboratories. Hazard classification: the process of evaluating available scientific evidence in order to determine if a chemical is hazardous. This provides us with the basis for the hazard information that is provided on SDSs, labels, and employee training. This evaluation identifies both physical hazards and health hazards. Physical hazards are as follows: fire, such as flammables or oxidizers; explosion, such as compressed gas or explosives; reactive, such as organic peroxides or water reactives. Health hazards are as follows: systemic effects, such as carcinogens, toxics, or irritants; and target organ effects, reproductive toxins or neurotoxins. Hazardous material entry routes. Now let's talk about the hazards you may find in the lab. Hazardous materials can enter the body in 4 different routes. Materials can enter through inhalation, which is through breathing and is the fastest way into your system. It is important that you understand what chemicals are being used when entering a lab, as some chemicals are odorless and can overcome you very quickly. Absorption occurs when a chemical is absorbed through the skin or eyes. This is why it is important to wear the proper personal protective equipment. Ingestion occurs when swallowing the material. Many people do not think about washing their hands after leaving the laboratory. But what if you had a microscopic hole in your gloves and you did not wash your hands before lunch or before heading home to your loved ones? It is important to think about these scenarios to ensure that you keep yourself and others safe. Injection, which penetrates through the skin, can occur if a contaminated sharp is thrown into the trash and a custodial worker goes to empty the trash. Please ensure proper storage and disposal of all materials within your lab. Types of exposures. There are 2 types of exposures: acute and chronic. Acute exposure is short-term exposure and symptoms tend to be seen quickly. An example would be a chemical burn to the eye or skin, as seen on the pictures on this slide. Chronic exposure is gradual exposure over time. Symptoms tend to be seen years down the road. An example would be asbestos exposure. Most people do not see the effects of asbestos exposure until 10, 20, or even 30 years after the exposure occurs. That is why it is important to understand what you are working with today, because it could have grave effects on your health years down the road. To reduce the chance of exposure, we need to identify the hazards, receive training, and use engineering controls, workplace behavior controls, and personal protective equipment. Because people are exposed to the chemicals with their work, the Occupational Safety and Health Administration, or OSHA, has set limits for the maximum levels of exposure an individual can be exposed to and not suffer adverse health effects, called Permissible Exposure Limits, or PEL. Exposure limits are published and enforced by OSHA as a legal standard. OSHA PELs are based on an 8-hour time weighted average exposure and can be found in tables Z-1, Z-2, or Z-3 of 29 CFR 1910.1000 on the SDS or through www.osha.gov. Clues that indicate exposure. In some instances, there may be indicators of exposure to hazardous chemicals. If there is an odor, you can taste the chemical particles that are in your respiratory system. You have acute symptoms, you see visible material in the air, or there is settled dust when there should not be. These may be indicators that you have been exposed. Seek medical treatment immediately after you have been exposed. Hierarchy of exposure control methods. On this slide, you can see the hierarchy of exposure control methods. The first one is elimination. If you can eliminate the chemical altogether, there are no hazards. However, that is not very practical when working in a laboratory. The next method is substitution. This consists of using different, less dangerous chemicals instead of highly dangerous ones. While these first two methods are the most difficult methods to implement, they are the most effective. Engineering controls are the next, and they remove a hazard or place a barrier between the worker and the hazard. Examples include chemical fume hoods and biosafety cabinets. Using safe work practices and administrative controls helps the worker ensure that they follow guidelines created for them to keep them safe while completing their work. Standard operating procedures, or SOPs, and proper housekeeping are examples. Personal protective equipment should be your last method used to control exposure. If you cannot work safely with all of the other methods in place, you must use PPE. Examples of PPE include gloves, safety goggles, and respiratory protection. Lab hazard information signs. One of these signs must be posted outside each lab. These signs are updated yearly and they provide critical information including 24-hour emergency contact information, lab hazards information such as NFPA diamonds and GHS pictograms. Always read the lab hazard sign before entering a lab. Emergency procedures. In the event of an emergency in the labs, contact Campus Safety and the Office of Risk Management and EHS. Campus Safety. Dial 2202 from any in-house phone, or dial 410-857-2202 from any phone to contact the Office of Risk Management and EHS. Ethan Harden, 410-871-3123. Katrina Wines, 410-857-2498. Sean Wellman, 410-857-2480. The contact information can be found on the lab hazard information signs posted outside of every lab. Medical emergencies. For incidents involving first aid and/or emergency equipment such as showers or eye washes, please contact Campus Safety and the Office of Risk Management and EHS and fill out the laboratory incident report. Then send it to the Office of Risk Management and EHS. Exposures. If you are exposed to a hazardous substance, inform someone immediately to determine the next step using the SDS or label. Flush the area with water for at least 15 minutes unless the SDS or label says otherwise. Contact Campus Safety and the Office of Risk Management and EHS. Always seek medical attention following an exposure. Once safe, report the incident to your supervisor. A laboratory incident report will need to be completed. Spill response. Students, if you can do so safely, block off any drains so the chemical does not make contact. Remove others from the affected area. Close the door to the room to contain the spill. Report the incident, including the chemical name, to a faculty member who will clean up the spill or will call for assistance. Spill response. Faculty and staff. Do not clean up a spill if you do not feel comfortable. Chemical spills under 4 liters. Remove others from the affected area. Ensure that you have a buddy to assist you. Spill kits are located in every lab. Use the correct PPE to ensure that you are protected from the chemical or biological, and then choose the correct material to clean up the chemical or biological that was spilled. Spill response. Faculty and staff continued. Ensure to block off any drain so the chemical does not make contact. Use tools to pick up any broken glass. Work from the outside in, as shown below. All cleanup materials must be disposed of properly. They should be put into a bag or container with a label and placed in the closest SAA. Send a laboratory incident report to the Office of Risk Management and EHS. Spill response continued. If the spill is over 4 liters or a highly hazardous chemical, evacuate the area immediately. Remove and notify those in danger. Close the door behind you, and then contact Campus Safety and the Office of Risk Management and EHS. Training requirements. Training is required for employees who work within a laboratory. At the time of initial assignment, yearly, or whenever a new hazard is introduced into their work area. You have reached the conclusion of the training. Thank you for participating. We hope you have enjoyed the training. Please direct any comments or questions to Ethan Harden.